calculus. We're doing slope fields and an added bonus, Euler's method. That's quite enough of that. Okay, so first thing, the book calls these things directional fields, but the rest of the world calls them slope fields, so we're calling them slope fields. Now, it really is pretty simple. What we're going to do is take a differential equation and plot it on a graph. So, let's try the differential equation y prime equals x plus y. Okay, so what this is saying is the slope of the function at any point is going to be the sum of the x and y values. So while we may not be able to solve that, we can plot points anywhere we want. So any x and y value, I can tell you what the slope is going to be. So what we're going to do is we're going to plot the points at every we're going to make it from -2 to +2 in both the x and y directions. So let's just make this, we'll make every 2 blocks 1. So here is -1, here's -2, here's 1, here's 2, and same thing this way. So this is 1, and this is 2. -1 and -2. So basically we're going to have rats. Okay, so we're going to find the slopes of this differential equation at all of these 25 points. So let's just start by making our table. So we're going to have an x value, a y value, and a y prime value. Okay, so it's kind of a crooked line. Okay, so we've got, let's just start with -2, -2. And then we'll just work our way up. So we've got -2, -1, -2, 0, -2, 1, -2, 2. Then we're going to go -1, -2, -1, -1. And then we'll go, let's go one more row. So 0, oops. All right, now, our slope is just x plus y. So -2 plus -2 is -4. -2 plus -1 is -3. And it's -2, -3, -4, -3, -2, -1, 0, oops, not -1, 1. Blew a tire there. Okay, now 0 plus -2, -2, -1, 0, 1, and 2. All right, now let's just go ahead and finish this table, so now we've got our -2s, our -1s, our 0s, so here's our 1s and our 2s. And so we've got okay, so now we get our slopes. 1 plus -2 is -1, there's 0, 1, 2, 3, 0, 1, 2, 3, 4. Okay, did I mess up anywhere? Very unlikely. Okay, so now all we're going to do is put those slopes on our graph. So we'll put them in red. Now let's put them in blue. I like blue better. Okay, so at -2, -2, the slope is -4. So there's my slope of -4 right at that point. Now it's not a slope of -4 everywhere. It's only a slope of -4 at the point -2, -2. So then at -2, -1, it's going to be a slope of -3. And then at -2, 0, it's going to be a slope of -2. You know, I didn't quite make that steep enough. This is where it gets kind of difficult because the difference between a slope of -3 and slope of -4 isn't that much. Okay, then this is -2. And then we're back up to -3. And then back to -4. So like I said, the difference in slopes here isn't that much. Now let's go to -1, -2, and we're a slope of -3 here. Okay, then it goes slope of -2, and then a slope of -1. Now we're starting to make a little bit of a difference, and slope of 0 here, and then we have a slope of 1 right there. Okay, now 0, -2, down here is slope of -2. Then we've got a slope of -1, then we've got a slope of 0, and then we've got a slope of 1. It's a little shallower than 1. Now here's the slope of 2. Okay, so now we go to 1, -2. Yeah, there's our 1, -2. It's a slope of -1. And then 1, -1 is a slope of 0. And then a slope of 1. And then 2. And then 3. Okay, now at 2, -2, we have a slope of 0. Then 1. Then 2. Then 3. Then 4. All right, so I've just made a slope field from -2 to 2 in the x and the y direction. Now, this shows an entire family of curves. It depends where we start as to which curve we're interested in. So if we start at 0, 1, okay, we start at 0, 1. Now you look at these curves almost like they're currents in water. And if you put a feather in that swirling current of water, where's the feather going to go? Well, we start at 0, 1. So there's my 0, 1. Now the current is pushing it down this way to begin with. But then we see that it levels off, and then it goes back up. So the current is basically going to be going like this. And now if it keeps going up this way, it gets steeper. So that's roughly my curve starting at 0, 1. Now, if I were to draw a curve starting at 0, negative 1, well, this time it's going down this direction. It levels off, and then it gets up steeper here. And then if I go this direction, it's getting, let's see it, 0, negative 1. 0, negative 1, it's negative 1. Okay, so it stays this direction, and then it goes up like that. So it stays at a fairly level negative 1 slope, and then it gets steeper as it goes up here. Now, if I start at 0, 0, then notice it's going up steeper and steeper, and this direction it's doing the same thing. So notice I've got red, black, green. I could start a curve at any point, and it would have a characteristic curve. So basically what we see here is this is a family of curves, and we're showing that entire family by making our slope field, which gives us slope at any point. And then when we start anywhere we want, that gives us a distinct curve. So that basically